These are in listen-only mode.
Hello, good morning, and welcome to this Edgecam webinar this morning. My name's Lee Richards, and I'll be taking you through some of the presentations this morning. Thank you everybody for joining. We've got quite a lot of people still coming on this morning, so it's now 10 AM UK time, so we'll make a start. Over the last 12 months, there's been a lot of discussion about the changes in Edgecam, particularly a term that we're using called workflow. And I'd like to revisit some of the technology shift that we've seen this morning over the last 12 months. Before we get started, just a couple of house rules please for the webinar. We really do welcome your participation. Please do ask questions. We have some panelists online today that can answer your questions. So please do ask questions as we go, and we'll get through those during the webinar this morning. Also, the webinar should last around 30 to 45 minutes, depending on the questions that we're getting. So, what will viewers see today? Well, first of all, what is workflow? We'd like to talk about the term workflow and how that integrates with Edgecam. And then we'll be looking at the different types of components that can be programmed using workflow. And also, a question here that we see, do I need a solid model? What happens when we don't have a solid model available to us? We'll be having a look at how we can create solid models inside the Edgecam environment. And also, what are the three levels of manufacture? This is a term that we're using inside Edgecam workflow, and we'll be having a look at each of those this morning. And most importantly, let's not forget, workflow is Edgecam, and Edgecam is workflow. Okay, so we'll begin with the three levels of manufacturing. And this basically is where we have three methods to approach how we machine the component. We can use full control, semi-automatic, and fully automatic. And what I'd like to show you today is how you can use each of those independently, and you can also mix and match. You can apply full control toolpath with fully automatic. We can apply semi-automatic with full control. And I'd like to show you the flexibility that we now have available to us inside Edgecam. Focusing on level 1, this is the full control. And this is what we call more of a traditional approach. And what we'll see in a moment is how we have full manual control over all the Edgecam commands within inside this environment. For example, we can pick a tool, we can apply move rapid, we can pick cycles. This gives us full flexibility, and this is what we deem to be more of a traditional method that we've seen historically in CAM programming. Okay, so let's get into Edgecam, and we're going to have a look at the first demonstration. So just to summarize the demonstration there, we're going to be looking at setting up the part, moving all the way through to NC code. And as you can see there, we're going to be considering the datum position, stock and fixtures, feature recognition, but I'd like to focus mainly on how we actually create the toolpath within inside Edgecam. So let's move across to Edgecam, and I'd like to start at the desktop. And when we install Edgecam, we now install with a launcher, and we have been using the launcher now for the last few releases. And this is where we can begin by entering workflow. Once we open workflow, we're greeted with a welcome screen. It's very informative. We've got the 5 steps of workflow. We've also got some excellent file management tools here. We can pin recent files and folders. And I'd like to start with the solid model that we see at the top of the list here, die block. So we'll begin by opening the file. And what we'll now see is Edgecam is considering the environment. So Edgecam has automatically decided that this part will be a mill component. It's also decided that the default datum position will be on the bottom left of the part. And we can influence this using the control panel here. We can move the control panel around the screen. We can influence the datum using the radio buttons that we see there, moving around the different areas of the component. So for this part, I'd like my date and position to be top left. We also have some other interactive tools that we can use to manipulate the part on the XY plane. Okay, let's focus our attention on the ribbon on the top left of the screen. We'd now like to consider stock material. We have a stock database, and this can be populated with your standard material sizes, castings, forgings, and we have three levels here. We have the valid. So the valid, as we can see, is a material which is suitable to produce the part. It's probably a little bit too big, but nevertheless it is physically possible to make the part from that stock. As I cycle down the list, you can see we have a different stock and another, and then we have yellow, which is nominal, and we also have the invalid stocks as well. So you can see here quite clearly why it's not possible to produce this component using the cylindrical stocks that we see there. So for this first example, I'd like to use the nominal stock, which will be a size billet. Select the part, and we now have stock material as we can see rendered here. Let's move across and select a vise to clamp the material. All the vices we see here again can be previewed and are standard with the Edgecam installation. You can add your own vices and clamps and fixtures. Finally, we select the machine tool. Here we have some sample machines. Today I'd like to use one of the sample machines from the installation, and I'm going to be looking at some 5-axis indexing shortly, so I'm going to go with a machine with an AC trunnion and a standard kit of tooling. So very quickly there, we've set the part up with the stock in the vise on the machine bed, and we're now ready to move to the next section, which is the features. So this is where we're now going to use Edgecam's automatic feature recognition. We're looking for manufacturable features, for example pockets, open areas, holes. Very quickly Edgecam will return the manufacturable features that we see on the top plane there. Okay, down the left side we can see the feature list, and we can now start to consider the manufacture of these features. As we're still using full manual control, for the first demonstration I'd like to focus on driving the system in manual mode. And to do this I'm going to activate the advanced toolbar. Now we'll see all the commands with inside Edgecam available on the advanced ribbon. So for example, I'd like to pick a tool, and I'm now selecting a tool from Edgecam's standard tooling database. This is a comprehensive database with many examples of different tool types, as we can see across the bottom. We support many different tool types, thread mills, T-slot, face mills, and we can filter accordingly. For this first example we'll go with a 10mm mill. Place that into position 1, and we now see we have the 10mm mill in the sequence. Next I'd like to use a roughing cycle. Just to take this from the pull down list, you'll see here we have a full comprehensive list of all the standard milling cycles, surface machining, 5-axis. Let's go with the roughing cycle. Here we can now see we've got the full power of Edgecam available to us through the cycle. Across the top we have the picking banner, which allows us to select geometry and boundaries. The geometry we wish to machine is the central pocket, so we have the 2D pocket feature there. We can now move through the cycle, influencing the manufacturing switches that we see here, offset for example, step over, speed, feed. But what I would like to point out is as I move through each of these areas, you'll see that I get a dynamic picture advising me on what will influence that change in that particular modifier. Finally, I'd like to influence the depth, or maybe increase that to 15mm, and calculate the toolpath. So this is what we deem to be the more traditional technique that our existing customers online today will be familiar with. And there we see the toolpath. We can interact with the toolpath, we get cycle time feedback, and we can interact once more and edit the toolpath with a double left click. Maybe we want to make a change to the step over and regenerate the toolpath. So once we've applied the initial toolpath, we can then go back and make changes accordingly, fine-tuning that toolpath to our requirements. Finally, we'll move the tool back to tool change before repeating the process, possibly picking a different end mill and finishing the pocket. And as you can imagine, we'd move around the part and we'd repeat this process, moving around the different features until we'd completed the programming of this part. Okay, so we're going to go back across to the presentation, and as I say, that was the level 1, using full control of all the commands and features within Edgecam. And what I'd now like to do is have a look at how we can speed up that process. So this is what we call the level 2 semi-automatic. This is where we have user interaction, picking the geometry that we wish to machine, and applying Edgecam's standard intelligent toolpaths that we supply with the standard installation. So as we've seen already, we've looked at part setup and position of the datum. We now wish to home in and focus on the application of the toolpath. So we'll go back into Edgecam, and what we'll do this time is still concentrating on the pocket for now, but rather than me picking the tool, then the cycle, then moving the tool, let's clear those toolpaths and consider the machine feature command that we see on the ribbon. Once we select the command, we now have options to rough, finish, or indeed rough and finish. I'd like to replicate the process I created manually by concentrating on roughing. I'm now asked for a piece of geometry to machine, which is the pocket, and what we should see now is Edgecam making the decision, picking the tool and applying the toolpath automatically for me. So I think you'll agree it's a much quicker way. I must stress though that once this toolpath has been applied, if I wish to edit the toolpath, it's exactly the same cycle. So you can use Edgecam's machine feature command and then go in and make the changes as we did before in exactly the same manner. Okay, and let's have a look at something a little bit more challenging. We can see around the part that we have some angled faces, and as I said, we're on a 5-axis machine, so we're going to look at some positional indexing. To do that, I wish to create some new datums. Using the new interactive CPL marker, we can simply drag, drop onto the face, position the datum, and we now have a new origin that we can index to. We can do that again, moving to the other side of the part, on the back side, and again I can influence the origin and we have another datum. So this is Edgecam's new datum creation tool. As you've seen me do that there live, it's very quick, repeatable and consistent. Now I wish to find the manufacturable features, but this time we're looking on a particular plane. I'm going to be using the 2 planes that we just created, and now we have some additional features that we can see in the feature tree. So once again, to manufacture those features, we can use the machine feature command, and this time let's have a look at doing some roughing and finishing. And I'd like to select the slot that we see and the open area, and we'll see that we now start to rough. We'll index round, so we can see we have the CPL index 1. Then we'll start to consider the stock condition before applying the optimum toolpath. Can you see there we're using waveform? And then we'll introduce a finishing tool to finish the walls. So the automation tools that we see as standard inside Edgecam not only consider 2.5D, they will also consider indexing. So for example, tombstone machining. Here we're looking at a 3+2 5-axis positional component. Because we understand the angle of where the feature is on the component, Edgecam's intelligent automation can get around to these features, applying the toolpath at the correct angle. Okay, so we're going to go back across to the PowerPoint, and we'll have a look at the next stage. Thank you for your questions that are coming in. Please do keep those questions coming, and if there's anything that we can answer along the way, please don't hesitate to ask our panelists as we go. Okay. So that was level 2. Level 3 is what we deem to be the fully automatic Edgecam toolpath application. We'll start to look at some different technology here, particularly the planning board. So as the picture intimates there, we'll see that Edgecam will plan the processes for the component before executing the toolpaths using the apply. This time we're letting Edgecam make all of the decisions for us. We can influence these decisions using some manufacturing options, and we'll be having a look at how we can set up our default parameters when we go back into the demonstration. For this demonstration, although I could continue with the previous part, it's not a problem, I would like to introduce a turning component and also an additional milling component. And across the top of my screen there, I've actually just put a small reminder that these are the tutorial components that we install, and I would encourage you to have a look at trying this for yourself on these parts and indeed your own components. So we're going to go back across to Edgecam, and this time using the file management tools at the backstage, we'll open up the part that we see here, which is the plate. And we've had a look at the part setup and the feature recognition already this morning, so I'd like to get straight across to the toolpaths. And this time we're going to use a tool here, which is the planning board. And what this will do is it will order the features and it will recommend a logical machining strategy. As you can see here, the first 6 strategies are to rough the pockets before finishing the pockets, spot drilling, drilling, tapping and counter boring. I can reorder, so I can drag and drop, and you'll see that I can rough the pocket and then finish the pocket. Maybe I want to do some drilling before I finish the pockets. So you can see there how, although Edgecam's recommending a logical strategy, it is flexible. We can make changes. So what I would like to do now is, using the fully automatic technique, I'll just reorder some of the finishing and get that back into a more logical order, and we simply apply. So rather than me interacting with the features, picking the features, Edgecam will do this fully automatically for me now, using the planning board and the apply. So you can see there that we're using the same tool, moving around the different pockets. As I've said before, you can influence this. We maybe want to pick a bigger tool and come back with a smaller tool and rest machine the pockets. I've elected to use one tool to rough the parts complete because I'm using waveform. It's a very fast, effective, high-speed roughing strategy with inside Edgecam. So we've roughed each of the pockets. We're now finishing the pocket walls, and then we'll move on to the drilling before finishing the holes. Okay, once the part's complete, what I'd like to do is actually move on to the last tab, which is the NC code generation. And we've also got some other productivity tools here where we can review the tool kit that's been used. We can look at the reporting tools coming out of Edgecam, particularly the job reports, which will give us A lot of valuable information for setting up the component at the machine tool. Okay, so we're going to move to the last stage, and that's the NC code. As I say, we can review the tools that have been used on the component. So here we can see that we've got the 4 tools that are used on the job. We've got simulation. I'm a little bit conscious today of the technology we're using for the presentation, and I apologise for any delay that you do get in the simulation, but we can just play this just to give you a feel for the simulation that we have within inside Edgecam. We've got full kinematic simulation of the machine tool. We've got collision checking against the part, the stock, the vice, and we're also checking the linear and rotary limits of the machine tool as well. Finally, we generate the NC code. And within minutes, the part has been programmed and is ready for production at the machine tool. Okay, so let's have a look at using a turn part. We'll just clear the part, and this time I'm going to use one of the tutorial parts. Notice how quickly Edgecam will switch the environment from milling into turning with 0 user interaction. The default datum position has been set. We could flip the part if we wish to start on the opposite side, and we can also influence the C-axis position using the interactive tools that we looked at earlier. Once again, we start to consider the stock material. So here we see that we've got a default stock length with finishing allowance on front and back. We select the machine tool. Before moving on to the feature recognition area, where this time we'll be looking for turning features. So we have turn profiles, faces, grooves, and we also wish to find some mill features as well. So here we've got some C-axis features, we've got some pockets, some open areas, and some holes. And the process is exactly the same again at the machining stage. We could use the manual approach. We could pick a tool, start to apply some of the turning cycles, but we wish to use the fully automatic strategy, which is simply to plan the job, and this time before we execute the automatic toolpaths, I'd like to just talk a little bit about where are the default values coming from. What is the default depth of cut? What is the default value for finishing allowance? Well, these manufacturing parameters can be influenced under the planning options. Here we have a fully comprehensive list of default values which you can influence. So for example here, the rough turning increment is 4. I wish to set that to 2.5 mil just for this demonstration. I could change the offset in X, and these are your preferred values that you wish to use, and they're available for turning, milling and drilling. Once we've set the values, we simply apply the toolpaths and let Edgecam take care of the manufacturing sequence. So the technology that we're looking at today is fully available in both the turning and the milling environment, considering C and Y axis components in turning, and also positional indexing with inside the milling environment. Okay, so while Edgecam finishes the machining of the part, let's move back across to the presentation and have a look at the next section. Okay, so the examples we've looked at this morning, we've been fortunate that we've had solid models available to us. Obviously, in real life there are instances where we don't always have that luxury, we don't have a solid model, so we must create the model. And at the latest release of Edgecam, we've now introduced technology which will allow you to create solid models inside the Edgecam workflow environment. And this is called EWS, Edgecam Workflow Solids. As you can see here, we've got many sketching tools available to us. We've got the ability to create chamfers, fillets, blends, holes, and we'll be having a look at creating the solid model from a paper drawing, from a sketch. This is ideal for clamps, fixtures and simple components. So let's move back across to Edgecam and we'll create a solid model, and then we'll go through the same process again of setting the part up before manufacture. Okay, so we'll just finish the part here and just start a new file. So we'll start a new mill part, and this time I'm going to use the new command EWS. This will launch the solid model environment with inside workflow. Okay, so now we can see that we've got the sketch tools across the ribbon. So I'd just like to make a simple mill part. We'll sketch out a rectangle. Not worried about the sizes at this point. We can come back and size that. We get automatic constraints. We'll maybe put a pocket within the part. And we can turn that into a solid model simply by extruding the part. We can drag and drop to influence the size, or indeed we can enter a user value of 50mm here. And very quickly I have a solid model created. For the pocket, I wish to consider the sharp corners by adding a blend. So here we can add a 10mm blend, for example. We can move around the part, selecting each of the corners, adding the fillet blends. Maybe we wish to add some more features on the top of the part, so for example some drilled holes. Select the plane that we wish to sketch on. Got different styles of hole. Maybe we want a countersink hole. Maybe we want to move across to a different area of the part and apply a counterbore hole. So very quickly we start to build up the part, and at any point if I wish to go back and make a change to the design, so here for example we could go back and influence the length of the part. So initially we're at 160, let's make that 175, maybe make the part a little bit wider, make that 90, and once we're complete we'll see that the solid model rebuilds. Once we're happy with the part, we can say done, and we can start to prepare the part for manufacture as we've already looked at this morning. So here we get the automatic alignment once again. We can influence the datum position. We could indeed drag a new datum onto the part. We can add stock before adding the vise, and as you can imagine we can move on carrying out feature recognition before machining the part. If I wish to go back and edit the solid model at any point, if there's a design change, we can simply interact with the solid and we're back into the modeling environment. Okay, so we've covered quite a lot already this morning, and once again thank you for your questions, and please do keep them coming as we get to the conclusion of the presentation. And what I'd like to finish off with really is just to summarise what we've looked at this morning. You know, the benefits that we can see there, hopefully the benefits are quite clear, especially on the speed that we're actually applying the toolpaths. The technology we have seen today is truly out of the box. You can install Edgecam, you can use your existing Edgecam installation exactly the way that I've been using it this morning. And obviously this gives us reduced implementation, and it makes the learning of Edgecam much easier. Ultimately, we're providing rapid, reliable and repeatable NC code, which will give us a fantastic return on investment. So, would you like to try what you've seen today? We are running a promotional campaign where we'd like you to test drive Edgecam Workflow. We will be launching this on the 1st of July, and if you go to the Edgecam website and then to test drive, please do get in touch with us if you'd like to have a go with the workflow technology yourselves. So thank you for attending this morning, and thank you to Ben for answering the questions and the other panelists on the line. If you do have any other questions, please do follow us on Facebook and Twitter. We've got plenty of information available on our social media channels and YouTube, and please do get in touch with us if you'd like to know more information. Thank you for your time this morning, and I will wish everybody a happy weekend.